Hello, hello, hello. All right, so in this video, we're going to go over the last Bohr worksheet. This is worksheet 3.4C. Okay, now the main purpose on this worksheet is to make sure that you can figure out a Bohr diagram, or for that matter, really any notation, but given various different pieces of information. So let's get started and see if this works. By the way, I'm using a different computer, so hopefully the mic is audible. All right, so when you are trying to, we're looking at part 2, by the way. We're going to start on part 2 here. No matter what kind of notation or diagram you are trying to draw, what you have to do first is figure out the number of protons, neutrons, and electrons. Once you have those, you can do anything you need to. You should be able to figure out an ion notation, isotope notation, Bohr diagram, Lewis structure, anything. We haven't done Lewis structures yet, but yeah. If you know how many of everything you've got, you should be able to figure out anything. So that's going to be kind of the main focus on this video, is making sure you can determine the number of protons, neutrons, and electrons. And that's all we're going to do on part 2. By the way, question for here, just put it, oh, hey, I haven't turned on the pen yet. Just put an X through this. We're not going to do that. Okay, we're just going to do this side for this question, for this part. Now, for the first question, it's pretty straightforward. I told you the number of protons, told you the number of neutrons, and obviously the number of electrons. So all you have to do is draw the Bohr diagram or whatever other diagram. So the one question is always going to be like this, so that one should be a cakewalk. On question 2 here, you're told that it is a neutral argon 41. Well, you have to figure out the number of protons, neutrons, and electrons. We're going to start with protons. There are 3 pieces of information in this question: neutral, argon, and 41. One of those 3 tells you the number of protons. It's the name argon, because you can go onto your periodic table, holding it up backwards, you can go onto your periodic table, find argon over here, and see that it is element 18. Okay, the blue number in the top corner is 18. That means that the number of protons in argon has to be 18. So we know for this one that P is 18. That's 1/3. Now we need to figure out the neutrons. Well, we can't get the number of neutrons directly, but we do know that this number right here is the mass number, because this is an isotope notation. Argon 41, element name, a dash, pointing it wrong, element name, a dash, and then a number. That's an isotope notation, which means that this number at the end is the mass number. If that's the mass number, then we can figure out the number of neutrons by taking the mass number 41 minus the number of protons 18, and that gives us that there are 23 neutrons for this diagram. And the last one we need is the number of electrons. Well, this one's really easy. There's only one thing left that we haven't used, and that's the word neutral. Neutral means the charge is 0. Okay, if the atom is neutral, the charge has to be 0. Well, if the charge is 0, the number of protons and electrons have to be the same. So, if there are 18 protons, then there have to be 18 electrons. And that gives us this one. Now, for number 3, I'm giving you you're making you do a little bit more work. It's to figure out the protons is exactly the same. I gave you the element name, so this is chlorine, so P is 17. Okay, that one's easy. Now we need to figure out the neutrons. Well, if you think back, for neutrons, we said that neutrons and mass number are tied pretty closely. So if we can figure out the mass number, we can figure out the neutrons. Well, between most common ion and most common isotope, the most common isotope tells us what the mass number is for this. In this case, and only in this case, when we are told most common isotope, we can find the element on the periodic table. Chlorine is right here. And this number right here, the average atomic mass, if we round that, then that will be the mass number for the most common isotope. So the average atomic mass is 35.453. If we round that, it's 35. So the mass number is 35. Well, if the mass number is 35, as we did up here, we can say mass number minus protons to get the number of neutrons. So 35 minus 17, is that 18? That gives us 18 neutrons. And that leaves us with the number of electrons. So the last thing we need to get. Now this time we're going to use the most common ion because the charge, if we can figure out the charge, then we can figure out the number of electrons. Well, chlorine, again, right here on the periodic table. And if you memorize those ionic charges that we told you you had to memorize, +1 and +2 for the S block, then over here we have +3 or -5. Positive or -4, +4 or -4, +5 or -3, +6 or -2, +7 or -1, and 0. So the charge for chlorine has to be either +7 or -1. Well, nonmetals have to be negative. So therefore, the most common ion for chlorine is -1. So if we know that the ionic charge is -1, then we can figure out the number of electrons by using the equation on the back of the periodic table. Right here, number of electrons is the protons minus the ionic charge. So the number of protons is 17 minus the ionic charge. So minus -1, two negatives, we add them instead. So we have 18 electrons. I am not going to go through and draw ion notations or Bohr diagrams because the main purpose of this video is to show you how to pull this information out and use it to draw the Bohr diagrams. The key is available online, so you can check your stuff there. The big thing for this is you need to figure out your protons, neutrons, and electrons from the various pieces of information provided. So we just did part 2. I want you guys now to pause the video, go up and do part 1, which is the top half of this page. Once you've done part 1, once you've finished it, unpause the video, and I'm going to go through the same process and show you how to get the number of protons, neutrons, and electrons for each of the 4 in part 1. Don't cross anything out like we did on this one. You actually need to be able to do all 4. Part 1, as well as parts 3 and 4, are almost exactly what your quiz is going to look like. So you have to know how to do this. This is what the Bohr quiz is going to look like. So pause this, scroll up to part 1, scroll up, go up to part 1, and try to figure out your number of particles there. All right, I'm going to assume at this point that you have done that. So let's go through and figure these out. So for the first one here, it just tells you P equals N equals E equals. So hopefully you figured this one out. Really easy. Now for number 2. Number 2 is a little different than anything we did in the practice. So hopefully, let's see if you guys were able to figure this out. So first off, P, the number of protons you can get in 2 ways from this. It gives you the element symbol O, which is oxygen, so you can look oxygen up on the periodic table. Or, if you remember how ion notation works, this number right here is the number of protons. So there are 8 protons on this one. Okay, next we want neutrons. In this case, this number right here, the 18 on top, that's the mass number. So then we can take the mass number minus the number of protons again. So 18 minus 8, there are 10 neutrons on this question. And that leaves us with the number of electrons. Electrons is going to be, if we don't have it directly, we need to figure out the charge. Well, the charge is the exponent here. So we can take the protons minus the charge, and that will give us our electrons. So 8 minus negative 2 is 10 electrons. And from there, you should be able to do whatever you need to. Coming back over to number 3. This time we have neutral beryllium 10. Beryllium tells us our number of protons. So P has to be 4 because beryllium is element 4 on the periodic table. 10 here is the mass number, so we can take the mass number 10 minus the number of protons 4, and that tells us that there are 6 neutrons. And to get electrons, once again, we are told it is neutral, therefore the electrons has to be equal to the protons, so there have to be 4. That is only true if it says neutral. If it doesn't say neutral, these 2 numbers are not going to be the same, so pay attention. Now, another way to do that is if the charge is 0. Okay, if I gave you an ion notation and the exponent here was a 0, that atom is neutral. Okay, so it's the same thing. Last one, I tell you boron in the question. So the number of protons has to be 5 because boron is element 5, atomic number 5. We can get the mass number from the most common isotope. If you look boron up on the periodic table, its average atomic mass is 10.812, which rounds to 11. So the mass number is 11. That means that the number of neutrons is going to be 11 minus 5, or 6. And for electrons, we want most common ion here. So the most common ion for boron can be either positive 3 or negative 5. And this is my bad because I forgot to mention this before you guys did this. But in class, I told everybody to use the positive ion, but I guess I'll show both. So if you do the positive ion, that means that the ionic charge is positive 3. If you do the negative, then the ionic charge is going to be negative 5. So if you do positive 3, then electrons is going to be protons 5 minus 3, which would be 2. Or if you did the negative, then your number of electrons would be 5 minus 5, or minus negative 5, or plus 5, which would give you 8. And from there, you should be able to do this. I will not give you one like this on the quiz. I'm not going to say, hey, find the most common ion of a metalloid, because metalloids suck, because they have 2 possible charges. So I will tell you specifically the charge if you're given a metalloid, so that this doesn't happen on the quiz. There are 2 more parts on the back of this worksheet, parts 3 and 4. They're basically exactly the same as this. They're just different elements, different isotopes, different ions. Okay, so go through, figure those out. draw the Bohr diagrams for parts 1, 3, and 4. Don't worry about part 2. And then you can check that with the key in Canvas. It's 2 pictures, so the key for the front is 1 length, key for the back is a 2nd length. But there you go. With that, I'm going to close this out because I got to record a couple more videos. So have a wonderful whatever, and I will see y'all next time.